Okay guys, so in this part we'll be talking about relational algebra. So let's get started. So what is relational algebra? It's a procedural query language. That means this takes relations as input and generate relations as output. That means the basic set of operation for relational model is relational algebra, and these operations enable user to specify basic retrieval request as a relational algebra expression. That means there are some operations here. So you will be giving some relation as input and we will generate some relation as output. That means first we will understand how it is if you know the different operations and what are the output that you're getting when you're doing that operation. So first is the select operation. So select operation is like the select operation is choose a tuple from a relation that satisfies a selection condition. So it is like the sigma sign. You can see this is the relation algebra's select operation sign. When I'm writing sigma and then this R represent what? The relation, the table name from which you need to select some tuples. I need to select some tuples which is satisfying some condition. So that condition I will write in here. Understood? So here is the relation name from which table I need to select. Now in which condition, what is the selection condition that I am using here, that I will write here. Let's see an example. This is my employee table. Suppose I wanted to select the tuple whose department is 4. So in here I will be selecting from the employee table. So my table name would be employee. Okay. And from which department number I told you is 5. So the selection condition is department number is equal to 4. It's not 5, 4. Now another example. Those salary which is greater than 13,000, such people only I need to select from the employee table. So in the employee table I am selecting only those people whose salary is greater than 13,000. Understood? This is how we are going to basically do this. We are selecting only those people whose salary is greater than 13,000. Let's see here. For example, to select the tuples for all employee who either work in department 4 or department 4 and make over $25,000 per year, or work in department 5 and make over $13,000. So how you are going to select that condition? First, either one condition, either you have to choose department 4 and making over 25,000, or I have to use department 5 and make over this much. These are the two. So I need to use or between these two conditions. I am using or. Now it says that it should be from department 4 and, so I will be using here and the salary should be greater than 25000 is my one condition, or department number is equal to 5 and salary is greater than 13,000 is my another condition. And from which table I am taking? From the employee table. So this is our complete selection condition. So from this table we will get the desired people who is satisfying this condition, either this or this, and condition is used to select that this two conditions should satisfy here. Understood? Now, so this is about the selection operation here. Now if you wanted to talk about the project operation, the project operation selects certain columns from the table and discards. Now this is used to select some data, particular rows from our table we are using the select. But now if you wanted to select a particular, let's say attributes only you wanted to select columns, then I am using the project. Okay, it selects certain columns from the tables and discards the other column. So that means this is my projection sign. It's like pi sign, right? And from which relation I am selecting, that table name we have to write. From which relation I am selecting the column name. Understood? This much we have understood. Fine. Now this attribute list is a list of attributes that I needed to take from this relation R. Let's understand from the example. Here, if I want to list the employees first name, that is here this is first name and last name and salary, these are the things that I want to use. Other things I don't want to project. So I'm going to project L name comma F name comma salary, right? This is how, these are the attributes that I want to show. So only that attributes data is going to be displayed like this. This would be the output of this particular project operation. Understood how this is coming? That is, if I want to project some particular columns, then I'm going to do this. Okay, now consider this example. To list each employee's first and last name and salary, whose salary is, then there is a condition, whose salary is greater than 30,000. So first of all, I needed to select only employee's first, last name and salary, but there is a condition for salary. Salary is greater than 30,000. So first I want to do is that I wanted to select all the details in which my salary is greater than 30,000. So I got one table from my relation employee. Okay, this is E represent employee. So in that relation, now I got a table which is containing all the details of all the people which is having salary greater than 30,000. Now from this table I am going to project the first name, last name and salary, right? From this table. Understood? So that means first I select the salary condition. This select should come here. Select where salary is greater than 30,000 from the employee table. Now this is one table that you got right now. From this table I'm going to project the last name. Should I project and salary also we have to project. Okay, so comma salary also you can write here like this. This is comma salary also you have to write here. Understood? Now to retrieve the first name, last name, salary of all employees who works in department number 5. So first I needed to create a table which is containing department number equal to 5 from employee. So now I go to the complete table of department number 5 only. From there I need to display only the first name, last name and salary. That is what this means. I hope that you combination of selection and projection, I hope you got how we are going to do the combination of selection and projection. This much we have understood. Fine. Now let us see union, intersection and minus operation here. This is the same thing. If you have two relationship and if I want to do union, intersection and set difference, how we are going to do between these two relationships. Okay, so they are said to be union compatible if two relationships have the same number of attributes and each corresponding pair of attributes has the same domain. Now how you can say if something is union compatible or type compatible is when they have the number of attributes in them is same, right? And each of these attributes in here A1 and B1 would have same data type. Let's say in A2, B2 would have same data type, then only we can say they are union compatible. See here, let's see student and instructor. They are union compatible because their first name, last name, they have only total number of attributes in them is what? Total number of attributes are same in both of these relations and the data type of F name and L name is same as F name and F name. Fn and F names data type is same. Lns and L names data type is same. So you can say they are union compatible. Now how do we do the student union instructor? First you have Susan. A student union instructor, how you are going to do is that student Fn, Ln won't come, right? So Susan, this would come and Ramesh, all these would come. Along with that, after that, what would come? The things with Susan and Francis. Susan is already there, Ramesh is also already there. Whatever which is not already there in the student, that is John, Ricardo and Francis. They are the people which is not there in the student table. Their details would also come when you are doing union. Intersection means which is common. Here Susan and Ramesh is common, so they will come here. Now student minus instructor means from the student I have to remove the things which is there in the instructor. So that means in the instructor there was Susan and Ramesh. So I want to remove Susan and Ramesh from there. Then I will display the rest like Johnny, Barbara, Amy, Jimmy, Ernest. All these would be displayed here. Similarly, instructor minus student means I have to remove Susan and Ramesh from there and John, Ricardo and Francis will be displayed in here. Understood? This is how the different union intersection minus operation actually works. I hope you have understood how the union intersection. So how, first of all, you have to check whether these two are union compatible or not, whether these two relationships are union compatible. Then only you will be able to do the union intersection and the minus operation here. Understood? Fine. On that note, let's understand here the Cartesian product. Cartesian product. Cartesian product, also known as the cross product or cross joint, which is denoted by this X sign, right? The X sign. It is also known as the cross product or cross joint. So, if you consider R cross S, that is a Cartesian product operation defines relations, that is concatenation of every tuple of relation R with every tuple of relation S. That means you can understand the Cartesian product only with example. You have student and instructor name. So here if you see roll number 1 here is a, and one name. When you are doing concatenation, roll number, name, this, all these things, instructor number, instructor name and subject, all these columns will be here. So for roll number 1, if you consider, there is Beena, and Beena's instructor name and subject would be, because instructor number 1 we will take, that would be Shamna and science. This much we have understood. Again we are taking 1 and you have to match it. So here this would go like this. Now Remu would also go like this. Shilpa would also go like this. That means first we have done for 1 Beanie, 1 Shamna and science. Now 1 Beena, 2 Anjali Max should also be there. Similarly, now 2 Ramu, 1 Shamna science would come. Now 2 Ramu, 2 Anjali Max, that would also come. See, this is how you are going to do the cross product. For this relation you have to do with all the things, cross with all the instructor, and when you take another student, that should also cross with all the instructor, and another student should also cross with all this. So if you take 3 Shilpa, it has to cross with 1 Shamna and science, 2 Anjali and Max. See, understood the cross product? This is a cross product. Understood? Now we are doing one important thing here, that is a joint operation. This is a very important thing, so you have to understand this very clearly about the joint operation. This joint operation is actually denoted by this symbol. See, this is a joint operation symbol. So how we are going to do joint operation, before we will be understanding very clearly, this is the most important thing that I want to teach you, is this joint operation here. And you have to understand that there is different type of joint operation here. See, we have equijoint or natural joint, left outer joint and right outer joint. First of all, let's understand natural joint. Natural joint can only be performed if there is a common attribute between the relationship, and the name and type of the attribute must be same. So first important thing for natural joint, let's understand what is natural joint. We are understanding what is natural joint right now. So understand this very clearly, that natural joint, if you want to do between any two relationship, if you wanted to do a natural joint, then there should be at least one attribute that should be same in both of them. If you see customer and order, CID is the attribute which is same here. Okay. Now when you do the natural join of it, see 101, all these things will be written here. Since CID is common, CID will be written only one time. So 101, let's say Ajay 20. So pizza 500 should be there. Now 102 is there, but here in the order there is no 102, so that would be not there. 103 is there. Okay, fine. So 103 would come here. 103 Sida 21, which is order number is noodles and cost is 300, but 104 is not there. So here, so only things which is there in both of those things only would be written here. Understood how natural join works? So there should be one attribute that is same, and the next thing that you have to notice here is that one attribute should be same, and the next thing is only those which is there in the if CID is common, then the CID which is there, the CID of 101 and 103 are only there in both of them, others are different. So only those CID which is same, their complete row only you have to take while you are doing natural join. Understood? Now, what do we mean by eq join? The most common use of join involves join condition with equality comparison. That means this is most commonly used. You are doing some comparison here. That means comparison means, see, there are two tables, customer, order. Okay. Now we have to we need only those values in which the customer ID, customer in the customer tables CID is equal to the order tables OID, and that condition from the two table, customer and order, you are doing eq join of customer and order and one condition. And what is that condition? The condition is that the CID and OID is equal. So where they are equal, 101 Ajay 20 pizza is the 101, also noodles is the right, 101 Ajay 20 noodles is also there. Then 103 Sida 21 burger. These are the things which is common. So CID, customer, how the natural join works, the eq join works is that under a condition, that is in the customer table, customers were, we have to show only those table where customer.cid, that is in the customers CID is equal to order.OID. That is, if this condition works, that informations only you have to show whether when this condition work of this two table, customer and order. This condition we will check. This is a eq join condition, and from this condition only you have to take the result. See another example. Retrieve the name of manager of each department. So first of all, I have employee here and this is my department. I have to retrieve the name of the manager. Now manager name is not there here, it is in the employee table because the names are here and some of them are manager. Fine. So the thing is that this is manager SSN number, this is manager SSN number, and this is super SSN number. This is the super SSN number. Fine. You have to understand here is that these are the SSN number of all the employees, and some of these SSN numbers are belong maybe the manager, that is 334, this is a manager, 9876543, this is a manager, 886, this is a manager. So I have to select first the data which is where manager SSN is equal to SSN. So first thing is that in the department and employee, I have to find, first I want to check whether the condition, the table, first I have to create a table. Now what is this arrow mark means? I am creating a table of manager first of all. That is what this arrow mark means. This result, the result of this natural eq join means I will get all the details of the person who are managers, their F name, middle name, last name, SSN, birth date, address, their sex, salary, super SSN, department number, department name, manager start date, all I will get of those which is equal to this, that I will put in this table. That is what this means. And from this table I need to I need only the name, so I need to only project the department name, last name and first name. So I get a new table which is the result. I need to show this result actually. So there is an intermediate table which is created, that is this department manager table. So this arrow mark shows that I am creating a table here. What does this arrow mark shows? Arrow mark shows I am creating a table here. Understood? I hope you have understood this. So first what I do is that I get whether when these two conditions are same, that table I get of all the details, that is the manager's table I got. Now in that manager's table I need to show only the name of the manager. So I show the first name and last name, and also I want to show in which department, so I show the department name also. Understood how eqjoin is worked and how we are creating intermediate tables? I hope you have understood that also, how we have created intermediate tables here. Understood? Fine. This is that thing that we have created right now. So next is left join. Okay, so now we have done natural join and we have done eqjoin. Natural join, I told you that we need something common should be there, and that common will be said only one time here, CID then CNAME. That joining the common things are the natural join. Then eqjoin, there is a equity condition that we are using in eqjoin. Now left join. Left join, the join returns all the row of the table on the left side of the join matching the rows for the table on the right side. That means A is the, B is the. I am doing left join of A and B. So that means 10, 20, 30 ID and names marks is the. So let's say name would be the something which is going to be common in both of them. So I have to display J Veer John. I have to display J Veer John. That means the left table should be completely shown. Left table should be completely shown. And but J's mark is not there in the B table, so that would come as null, because the condition of left join is that before and all, when we do the natural join and all, there would be a common thing, like here name is the common, fine. There would be some attribute name which would be common, and only those which is there. Here Veer and John is only there. Only their data would be shown here in natural join. But in left join means the left table would be completely there, and if there is no data in the B table, null would be there. Understood? So right join means what would be the opposite. The right table would be completely there, like Rohan, Veer, John, Sam. This is my right table. That would be completely there, and if there is no ID which is there, the others null will be described. Understood? That is difference. So if left join means the left table would be completely shown, and the matching right table would be right values would be there. If there is no matching right value, then we will put the value as null. Understood? And in the right joint, that means in the right join, the right table will be there and the left table matching things only will be there. If there is no matching values, then null values will be there. That is right join. Now let's understand full join. Full join means we will be writing all the table, that is ID full table will be there, then this also, B also full table will be there. Okay, now see here 10J doesn't have marks, so you put null. Now 20 Veer has marks 18, 13 John has marks 14. Okay, now in this table we have to use Rohan also. Rohan 20 and Sam 13 should also be there, but they do not have ID, so they put the value null. Here both the table completely should be ignored. If there is no matching, their values would be respectively placed as null. Understood? This is how we are going to do the full join. So in the next we will do, next video we will do some university questions, and also we will do more questions from other sites. Thank you.